Hello, in this video I will talk about organs of immune system. So our immune system is just comparable to a defense system of a country. A defense system of a country has all its defense division, its air force, its special task force, its navy, everything like that. So our body also has all those kind of divisions of immune system. Now, just like every country has its barrier, has its border secured by fences and army patrolling near the fences, our body also has skin which works like a physical barrier. Through this fence, terrorists or outer immigrants cannot come directly in because there are armies who are actually securing the border. Just like that, our skin is a physical barrier. Now, skin contains a lot of proteins and short peptides which are ready to combat microbes and germs. These proteins include lysozyme, calprotectin, lactoferrin, defensin, cathelicidin, etc. and etc. All these proteins have antibacterial property. They interfere with some life processes with the bacteria or other germs and don't allow pathogen to come in. Also, the pH of the skin is tightly regulated such that pathogen growth or bacterial growth on our skin is prohibited. This is how our skin works like a physical barrier. Now we would talk about primary lymphoid organ because our immune system has two major divisions in terms of organs: primary lymphoid organ and secondary lymphoid organ. Primary lymphoid organs are those organs where immune cells develop. So the primary lymphoid organ in our body is bone marrow and thymus. Bone marrows are mostly found in long bones, such as depicted here in the picture. So inside that bone, there are bone marrow endosteal niche. There are vascular niche around the blood vessels which circulating around the inside the bone. Now, bone marrow has hematopoietic pluripotent stem cell. That means it can give rise to all kind of blood cells. Then hematopoietic pluripotent stem cell divides into myeloid progenitor or a lymphoid progenitor. From the lymphoid progenitor, the adaptive part of the immune system develops, whereas from the myeloid progenitor, mostly the innate immune system develops. Lymphoid progenitor give rise to immature B cell, immature T cell, and natural killer cell, whereas myeloid progenitor give rise to macrophages, monocytes, panned basophils, panned neutrophils, etc. and etc. Now, another important primary lymphoid organ is thymus. Thymus is known as the training school for the T cell. T cells are born inside the bone marrow, but in the immature state, they are sent to their school, which is thymus. They go to the thymus, receive thymic training, intense training they receive there in the thymus, and become mature T cells, either a helper T cell, a reserve bench of an army, or direct cytotoxic CD8 positive T cells. That means combat ready army. So here is an image of thymus. In a cross-sectional view, you can see there is sequential development happening inside the thymus. There are stages known as double positive stages where there is an equal chance that a immature T cell can become either a helper T cell or a CD8 positive T cell. But sequentially, when they interact with follicular dendritic cells, those T cells which choose to recognize antigens on class 2 MHC molecules, they become the CD4 plus helper cells. And those who choose to recognize class 1 bound peptides are becoming CD8 positive cytotoxic T cell. Now, also the secondary lymphoid organs are actually places where the T cell or B cell or any immune cell does not develop, but they just differentiate there. They are not born there, but they are brought up in that places. So secondary lymphoid organ, one of the most important secondary lymphoid organ is lymph node, because lymph node is kind of all around the body, and several lymphatic vesicles bring in lymph to those lymph node, and also lymph node is connected by veins and arteries. So lymph node is just like a army base camp. So inside the army base camps there are different areas. Just like that, there are different areas for residing of T cell and B cell. It is heavily compared to an army base, where there are several barracks where different divisions of army members can live. For example, in the lymph node, inside the germinal center or lymphoid follicle, B cell resides, where in the paracortex, T cell resides. Now we talk about the biggest secondary lymphoid organ of our body, which is spleen. Spleen is specialized for trapping blood-borne antigens. Spleen is an encapsulated organ just underneath the liver, and it is highly vascularized, and it has a lot of blood supply such that blood can take all the blood-borne pathogen and dump it into the spleen. Now spleen is known as the graveyard of RBCs. So RBCs are recycled, and also spleen is compared as a big army base. So there are definitely barracks for T cells and the B cells. So if we take a look at the cross section of a spleen, we would find two major regions. One is a red pulp, one is a white pulp. Now in the white pulp region, it forms actually a sleeve-like area around the arterioles. So this is known as periarteriolar lymphoid sheath, or easily known as pulse. And this is the house for T cell. Whereas there are some follicles around the pulse, which is the house for the B cells. Now, just like lymph node, spleen is also home for T cell and B cell. So those are the base camps. Now, other secondary lymphoid organs are mucus associated lymphoid tissues. They reside in respiratory tract, they reside in many other places, but one of the most important is the Peyer's patch. Peyer's patch is found in the intestine. So it's a patch of lymphoid tissue present in the intestine, which also houses several T cells, macrophages, and dendritic cells, which are important or secondary organs for immune system. So that concludes my video on organs of the immune system. So if you like my video, give it a quick thumbs up. Please like my video, subscribe for more updates, and don't forget to share this video among your friends. Thank you.